Welcome to infinite range examples. So for our first example, let's go ahead and evaluate the improper integral, which is the definite integral from 0 to 1 of 1 over the square root of x dx. So just a quick note, 1 over square root x has a vertical asymptote at x equals 0. So if we were to draw the picture, we have our vertical asymptote at x equals 0. At 1, we're equal to 1, and then it goes down to the right. We are taking, we want to go definite integral from 0 to 1, but since at 0 we're infinite, we'll take something a little to the right of 0. Call that t. And we'll take that definite integral from t to 1. And then we will let t head to 0. So we have our definite integral from 0 to 1 of 1 over the square root of x dx is defined as the limit as t approaches 0 from the positive side, and the definite integral from t to 1 of 1 over the square root of x dx. This is simply the limit as t approaches 0 from the positive side of 1 over square root x is x to the negative 1/2. That goes to x to the positive 1/2, and then we would have to divide by 1/2. Evaluated from t to 1. So we are looking at the limit as t goes to 0 from the positive side of 2 times the square root of x, evaluated at t and 1. This is, of course, the limit as t approaches 0 from the positive side of 2 minus 2 times the square root of t. 2 times the square root of t will go to 0 as t goes to 0. So we have 2 minus 0, better known as 2. So the definite integral from 0 to 1 of 1 over the square root of x dx is equal to 2. Now let's go ahead and take a look at another integral, which we will have to split. So in this example, let's evaluate the improper integral from negative 1 to 1 of 1 over x squared dx. So again, note 1 over x squared has a vertical asymptote at x equals 0. So if we were to draw our picture, 1 over x squared, we have our 1 over x squared graph in the first quadrant, and then its mirror image in the second quadrant. We're going from negative 1 to 1 with our problem at 0. So what we will do is we will stop at a t value a little before x equals 0. And we will start at another little t value above x equals 0. You can use lowercase t and capital T if you like. We will take these two separate integrals, one going from negative 1 to that t a little before 0, and one going from the t above 0 to 1. And then we will let those two t's head towards 0. So the definite integral from negative 1 to 1 of 1 over x squared dx, we will define as the limit as lowercase t goes to 0 coming from the left, the definite integral from negative 1 to t of 1 over x squared dx, plus the limit as capital T goes to 0, coming from the right of the definite interval from t to 1 of 1 over x squared dx. So 1 over x squared integral is just a negative 1 over x. So this becomes the limit as lowercase t approaches 0 from the left of a negative 1 over x evaluated at negative 1 and t, plus the limit as capital T approaches 0 from the right of a negative 1 over x evaluated at capital T and 1. So this first limit, we are looking at the limit as t approaches 0 from the left of negative 1 over t and then we would have minus negative 1 over minus negative 1 over negative 1. All right. And then we will have plus a limit as t approaches 0 from the right of a negative 1 over 1 minus a negative 1 over t. So this becomes the limit as t approaches 0 from the left of negative 1 over t minus 1 plus a limit as capital T approaches 0 from the right of negative 1 plus 1 over t. This gives us, if we go from the left, t approaches 0 from the left, negative 1 over t will go to a positive infinity. And then the limit as capital T approaches 0 from the right, a positive 1 over t will also go to a positive infinity. So we have an infinity plus infinity case, and we just wind up with positive infinity. So in this case, we get that our improper integral is unbounded and it is infinity. In the next videos, we will look at some special cases of what we get for improper integrals when we are looking at 1 over x to the p.